Hello everyone. I'm Kavita Agarwal, Associate Professor, Department of Computer Science and Engineering, Integral University. Imagine a world where billions of objects can sense, communicate, and share information. All of them interconnected over public or private Internet Protocol networks. These interconnected objects have data regularly which they are collecting, analyzing, and it is being used to initiate some action, which is providing a wealth of intelligence for planning, management, and decision making. This is the world of Internet of Things. We will talk about an overview of Internet of Things. In this session, we will cover number of topics. We will talk about introduction, how it started, evolution of IoT, enabling technologies for IoT, domains of connected devices, state of the art, IoT security and challenges, implementation of IoT projects, scope of IoT, career as IoT developer, and a summary. Before we start with the presentation, if we just look at the general scenario, IoT painting a picture of future world. If I look at businesses, it holds a lot of promise for businesses. For gaining competitive advantages, helps in collecting and analyzing massive amount of structured and unstructured data and improving business process. If I look at leveraging market, it is automatically sensing and prompting analysis of thousands of services and automating the service of providing services. If I look at intelligent surroundings, it enables objects in the surroundings to efficiently sense and then collect information and use it for intelligent decisions. It is inexpensively communicating and creating a better environment. Now let us look at what is Internet of Things. Internet of Things may be considered as a network of physical elements empowered by sensors which we need to collect information. We have identifiers which identify the source of data, that is the place from where we want to collect the data. Then we have to have a software which analyzes this data and an internet connectivity to communicate and notify. So, Internet of Things is a network of things with clear element identification, embedded with software intelligence, sensors, and ubiquitous connectivity to the Internet. Internet of Things is an internet of three things basically. People to people, we have communication between a person and another person through various devices. We have people to machine. We have machine to machine, or we can say thing to thing or a thing to machine. They are interacting through internet. So if we see the definition or rather the reference given by Cisco to Internet of Things, they refer to Internet of Things as Internet of Everything. It has four components. It has people, that is, it is connecting people in a more relevant way. It has data, that is, converting this data into intelligence to make better decisions. There is process for delivering the right information to the right person or machine at the right time. There are things or the physical devices and objects connected to the internet and each other for intelligent decision making. So if we look at this diagram over here, we have four components, and together these four components are making Internet of Things. We have people, we have things, people which are connected with the help of internet, So internet is a very, very important component. We have things or the devices or the objects. We have process which is delivering the right information to the right machine or to the thing or to the person where it is needed and for which it was being processed, and the data which is collecting data and it is converting it into some intelligent data so that it can be used for better decision making. If we see how all of this started, the concept of adding sensors and intelligence to physical objects was first discovered by some university students in 1980s. There was a Coca-Cola vending machine and they wanted to track its contents remotely so that they don't have to go there and physically verify whether it has the components which are needed or the cola bottles in it or not. So what they did was they developed a system which could help them track whether there were cola bottles in the vending machine or not. This system ultimately was, or we can say this was the starting point of Internet of Things. To start with, this was a very, very expensive and a bulky system, but it gave us an idea or a concept which is the major thing now. So if I look at the evolution of Internet of Things, if I see there's a little mismatch over here. So we started with Internet in 1969. In 1993, GPS or the Global Positioning System became a reality because we had global positioning satellites which we could use for locating various devices or the various people or the various machines which we were trying to communicate with. In 1999, it was a big year for IoT because IoT was officially named by a scientist, Kevin Ashton, and he also gave the definition of IoT. The term IoT was coined by the scientist while working at Procter & Gamble. He proposed putting a radio frequency identification chips on products to identify them and to track them through the supply chain. And then in his reports, he included the term Internet, which got the attention of the executives, and the phrase struck. So now there was a term of there was Internet, there was term thing, and the term which was coined was Internet of Things. Then in 2000, the LG announced their first smart refrigerators. These refrigerators could sense what was inside them. They could sense their expiry dates and they could inform the user that which items are about to be expired. So that there was less wastage and things could be preserved. Then we had our iPhones. Then we were testing the driverless cars. Then we had thermostats which could control the central heatings, which work like remote controls, and then this list becomes endless. Currently, we are not just restricted to these applications, we have many more applications. So if I look at the technologies which enable Internet of Things, they can be grouped into three categories. We can say that we have to have a technology which will help us acquire the contextual information. That is, if I am trying to sense something, I have to have a technology which will help me acquire or to sense that data. So I need a technology to acquire contextual information. Once I have this information or the data, I should have a technology that should enable the processing of this information. So the processing is the next part, and then I should have technology to improve the security and privacy of the data. So once I have these technologies in place, then only I can have a successful implementation of Internet of Things. So once I have these technologies in place, I will have a successful Internet of Things. So if I see my devices, my connected devices fall into three user domains mainly. We have consumers, we have enterprise, and we have public spaces. If we see the consumers, we have these wearables. If I may say, most of us are using smart watches now. They are part of our IoT devices. We have these Amazon Echo speakers. We have smart meters. We have smart water heaters, which we can control sitting anywhere with the help of our mobiles. We have home automation systems. If I look at enterprise, we have smart factories. We have precision agriculture. We have smart greenhouses. These greenhouses are able to measure the humidity, temperature, and various parameters which are needed to maintain the ideal conditions for the plants which we are growing in the greenhouse. We have smart equipment and smart infrastructure. We have smart products. We have smart security. If we look at public spaces, we have waste management, which is smart in the sense it can detect whether the waste is being collected properly, whether bins are full, do we need to dispose them off. We have wireless water meters, we have license plate readers, we have healthcare systems. So all these connected devices which we are using even without knowing are making our life so much easier and simpler. If I look at the characteristics of Internet of Things, first thing which comes to our mind is interconnectivity. All the devices, all the communication, and all the data which is being collected, processed, and then being used for making intelligent decisions is all dependent on the interconnectivity. So interconnectivity is a very, very important characteristic of Internet of Things. We have to have proper interconnectivity for the successful working of any device which is on Internet of Things. We have things related services. Every service which is related to a particular thing or a particular machine has a particular objective and it has certain limitations. So all the services are to be towards that objective with, or rather working within the constraint which is related to that particular thing. And the devices which we are connecting all are working on maybe different platforms. They have different hardware. They are using different operating systems. They are using different softwares, and still they are being connected and they are working towards a common goal. So that is where the characteristic of heterogeneity comes. We do not have a homogeneous platform on which all the devices are working. This is working successfully because it has the characteristic of heterogeneity. The number of devices which are being connected, which are working, the kind of data which we are connecting, that is also changing with time. So it is very, very dynamic in nature. And the data which we are connecting is very, very huge. So it is enormous in scale. Number of devices which are connected is not limited to 1, 2 or 5 or 10. That becomes a very, very huge number. So the scales of working is very enormous. Safety, we have to see the characteristic of safety at two levels. We are talking about the physical safety and we are also talking about the safety of the data. So the devices, the characteristic of IoT is that it is safe for the person who's using it in terms of physical safety. All the wires and everything is properly connected and sealed, and then the data which is being transferred has to be, or rather is being done quite safely. And then connectivity, and again it is related to interconnectivity. If the device we want should be on Internet of Things, it has to have a connectivity so that it can sense the data, maybe send it for processing, and then receive instructions what is to be done further. So connectivity is a very important characteristic of Internet of Things. So this is just a few examples. We can talk about the things which we take for granted, which are all around us and which are basically come under Internet of Things. We have smart refrigerators, we have smart watering systems for farmers. These systems will sense the soil moisture, it will sense the humidity, and it will also sense the requirement of the plant, and then accordingly the plants will be watered. This is a very, very good system. This helps us to save water, which is a very, very important commodity in the current scenario. Then we have smart sensors which will predict natural calamities like floods, earthquakes. Then we have smart grids, we have energy management systems, we have smart cities, we have smart home with all the smart gadgets in it. Then we have patient monitoring system, it is there in education, we have it in transport, smart infrastructure and agriculture. But if I see, I can categorize these things into some specialized categories. If I can say that, we have Internet of Smart Living. Under this I can put all my home appliances which I can control through a remote control, maybe through an app in my mobile phone, and I may be sitting at my workplace and controlling these devices at home. We have these weather devices which will tell us what will be the weather of maybe the place where we are sitting, or some other place where we want to visit, or whether we are interested in knowing their weather conditions. We have smart home appliances. We have safety monitoring, which is a very important application of IoT. We place these smart cameras in our homes. They will monitor any kind of intrusion, or even if I just want to keep an eye what is going on in my home in my absence, these devices will help me. Then we have intrusion detection system which will send me alarms if any unusual activity happens in my home. We have Internet of Smart Health. This has devices like patient surveillance. It will help us monitor. We may not be present next to the patient all the time, or the healthcare worker may not be present next to the patient all the time. So we have these patient surveillance systems which will help that healthcare worker to identify a patient in need of immediate help. Then we have these medical fridges in which we keep our vaccines and medicines which are to be kept at a certain temperature. Then we have this fall detection, maybe for the elderly, we want to keep an eye how that particular person is doing. Maybe there is some elderly person who is living alone. Then these systems will help us provide them timely help. If they are not well, maybe they have fallen down, or maybe they are in need of some medical help, it can be provided to them. This dental assistance is a very, very interesting application. We may put a small device in our toothbrush, and when we are brushing, it will check the health of our mouth. It will check whether I am cleaning my mouth properly or not. Am I brushing correctly? Maybe there are few cavities which it will detect, and it will inform maybe the person or maybe the doctor that this is the scenario. Then we are always hearing about smart cities these days. We hear about Internet of Smart Cities. So in Internet of Smart Cities, we have structural health system. It is like every building has some structure, and we are trying to monitor the health of that structure. There are a number of vibrations maybe there was an earthquake in the city, there was some heavy traffic which passes nearby, which causes some vibrations in the environment, which is affecting our building. So it will check the structural health of the building, it will check whether the building is safe, is it able to tolerate those vibrations, or if there is some repair which is needed, it will indicate. Same is for the lighting. If I'm at a particular room, maybe the light should be on. If I go out of the room, the light should be shut. So it works towards conserving the energy. We also talk about safety. We have these safety cameras. If there are any unusual activities which are detected, it will alert the system. Transportation, smart parking, waste management, all these applications come under Internet of Smart Cities. Then we talk about Internet of Smart Industry. If an industry is dealing with hazardous gases, maybe explosive gases or explosive material, or any other material which needs some kind of special attention, then we have these smart devices which will help us manage it. Then of course, maintenance and repair is another place where Internet of Things is very, very useful. It will indicate if it sees some kind of cracks which are to be repaired, or maybe there is a faulty piece which needs to be repaired. In the assembly line, if it discovers there is a need of maintenance or repair, so that can be prompted with the help of these devices. Then we talk about Internet of Smart Energy. Energy, if I see, is a very, very precious commodity. We have these smart grids which will help us conserve the energy. These wind turbines are there. We have power supply controllers, and we have these photovoltaic installations. Then we have Internet of Smart Agriculture. As I was telling you earlier, we have these greenhouses. These have all the equipment in place which will check the humidity, temperature, moisture, and all the parameters which are needed to grow that particular crop inside the greenhouse. And if anything is needed, either it will activate that particular actuator to do that, or it will prompt the required person to take some action. Then we have these compost pits where it can check whether the bacteria is flourishing properly or not, or do we need to add more culture to it. So that can be prompted with the help of these devices which are put there. Then we have these animal farmings in which we can use the trackers and other devices which are needed. Offspring care is there. If we have these babies which are to be looked after, for that we can have these Internet of Things. We can put these small cameras over there which will monitor and will prompt if any need or any action is to be taken. We have field monitoring systems also. If I see, we have another application which talks about smart environment. Environment, currently if I see in the newspapers or we read it everywhere, we are talking about pollution. We are talking about how to save our environment, how to reduce the pollution. So if I want to reduce the pollution, I'll have to monitor it. So we have these smart devices which will monitor the air pollution. It will detect if there is any forest fire just at the beginning itself, so that it can be controlled as soon as it starts. Then we have weather monitoring system which will prompt us if it is sensing some kind of disaster which is about to be happening. Something like maybe there's a flood which is about to come, maybe there is some kind of avalanche which is going to happen. So these weather monitoring systems will prompt us for that. Then we have systems which will check the quality of water quality of natural water bodies, and it will tell us that the effluent which is being let into that water body, what is it doing to that water body? Should it be further processed, whether it is being correctly processed or not? And of course, we have systems for protecting wildlife. Like if we have a railway track passing through a forest, and that forest has number of animals which will cross that particular railway line, so it will have devices which will prompt the train driver that a particular animal is crossing the railway line, so it will either stop the train or it will slow down the train. So these kind of devices and the application areas for IoT is making it very, very useful and very, very important. To have these systems, there are certain challenges for IoT. Challenge is privacy and security. If I'm sharing all the data, or the data is being sensed all around me by various devices, my privacy may be breached. So that we have to be very careful when we are designing any IoT system, that the privacy and security, these 2 points are considered when it is being designed. When we are designing, we also see the usability part. What do we want out of the system? But we forget the cost. To make any system viable, we have to consider the cost of that system. So we may have to have a trade-off so that the system is viable. Trade-off between cost and usability. Then we have this interoperability. The devices which we are going to connect are heterogeneous in nature, as we had talked about it earlier. So if the devices are heterogeneous, then our system should be able to handle it. And the data which we are generating is huge, so the data management is also a very big challenge. Of course, since these devices are to be put at various locations which may not be very, very affluent with energy, so the device level energy consumption is always a challenge because we are always trying to reduce it. So if we look at a very important area, IoT security and challenges. So if we see over the time, due to its evolving nature, considerable number of manufacturers and service provider companies took this opportunity to build a new business models with improved efficiencies and better services. However, all this led to a new kind of threat which we call as IoT security. The IoT ecosystem poses a new security challenge that extend beyond the traditional security system. Traditionally, we were talking about internet security, we were talking about network security only. But in this, it has extended beyond that. If we see the security challenges in IoT, we have software and firmware vulnerabilities. That is, lack of computational capacity for efficient built-in security. If I see my IoT system, it is a very, very small system which I have embedded into a big system. Maybe my washing machine has a small IoT system built into it. So the computational capacity of this device is very limited. So it may not be able to handle the security very effectively. So that becomes a challenge. Then how to manage security in IoT? We have poor access control also because it is limited capacity, it has limited computational capabilities, so that becomes a challenge. Then the communication challenge which it is, or the communication channel which it is using, is very insecure. Traditional security measures are inefficient for protecting the IoT device communications. So we have to work on that. we have an attack which we call as man in the middle attack. So that is a very, very common attack for IoT devices. We'll briefly talk about various attacks which pose a challenge for IoT devices. Then there are data leaks from IoT systems. We have sensitive data such as location, bank details, our confidential information, maybe our health record, which may be leaked from our system because there may be some in between hackers which will hack our data. There is a possibility of malware in the IoT devices. Attacker can inject this malware into our IoT system even without us knowing, and it will change its functionality and will also start collecting our personal information and the information which we want to keep secure. So 5 common cyber attacks in IoT are denial of service attack. This is a very, very familiar attack to us. In this, a device's ability to respond to legitimate request is compromised because we have flooded it with fake traffic. Then it has denial of sleep attacks. If I look at any IoT device, it is consuming some energy, and since it is most of the time battery operated, I want to conserve that energy. So what we do is we make sleep cycles for it. There are sensors, and in the sensors there are sleep modes. This sleep mode preserves the battery and the energy of the device. But what happens in this attack? The device is not allowed to go into sleep mode, and this is how it keeps on consuming the energy and ultimately drains the battery power, and thus it disables it. Then we have device spoofing. We are very familiar with this. This is because we have poorly implemented public key infrastructure, and for this again we have to see to it how to improve it. Then we have these physical intrusions. That is, a person physically accesses our information, comes into the vicinity of the device, and then takes the access of the information. Then we have application-based attacks. Maybe there is a particular application, a software or a firmware which is attacking it, which is breaching all the security and collecting information. So when we are implementing any IoT project, there are a number of things which we have to keep in mind. First, we have to identify the objectives. Why do we want to build this IoT project? Or this particular system, what is the need of this system? What is the input which we are going to take into the system? And what is the output we want out of this system? A careful study and a proper requirement analysis is needed before we start implementing any IoT project. Then, once we have identified what is the input, what is the output, we will also understand what kind of processing is needed to convert this input into that particular output. For that, we need some components of IoT. So the next step is to identify those components. We should not just take the components which are usually taken or which are fancy sounding or which are there in the market. We should only take which are needed for our project. Once we have these components up with us, we should first try and implement a prototype. Once this prototype is successful, and then only we should go about implementing it. If we see the IoT projects, we are not restricted to just one machine. If I build a component for a washing machine for some company, then if that company is manufacturing 1000 washing machines per day, then this component goes into those 1000 machines every day. So we have to be careful. So the prototyping and implementation are very, very important aspects. If there is a small failure in our device, that will be replicated to thousands and thousands of machines. So the prototyping implementation has to be done carefully. Then we also have to ensure, or rather keep in mind, that the technology is advancing every day. So it should have the scope of incorporating those advancements into the device. It should be scalable. And whatever security measures which are required should be in place, because we are transmitting data from one end to the other. So this has to be through a secure channel. So when we are implementing any IoT product, because of its scale, that it has to be implemented in such a large scale, there are a number of things. There is compatibility and longevity issues. If I put it into simple words, since it is heterogeneous environment, so there is an issue of compatibility, and since the technology is advancing every day, there are new advances. If it is not scalable, we won't be able to use it for very long. So compatibility and longevity are very important issues. Then of course security issues are there. Data storage. Since we are generating so much of data, it is going to one place where how do we store it? How do we process it? And then how do we use it to improve services or for whatever it was designed for? And of course the power management of the IoT devices. Now coming to, if IoT is very, it has prompted me to think of it as a career for myself, then if I'm looking at career as an IoT developer, then there's a small overview which I would like to give. What is the role of an IoT developer? A role of an IoT developer is to create, or rather creating, developing devices, sensors and software. It also researches, it creates and tests the IoT solutions. Another important role is documenting. Documenting is usually thought of it as a very, very last job, but it should not be the last job. Then the background which is needed for IoT developer is the basic computer science or computer science and engineering or an equivalent technical field. Skills which are needed: in-depth understanding of computer programming and network security, and proficient knowledge of sensors and actuators, because sensors will help me collect the data and actuators will help me implement whatever action I want to take. So coming to the end of my presentation, I would like to summarize it. So if we can say that from the soil moisture sensors to notifying room temperature, the Internet of Things is transforming the way we live and work. The range of potential IoT applications is limited only by human imagination. It is unlimited. It will go as far as we want to take it. But for all the benefits, IoT technologies can also be misused, and the risks include security and privacy issues. Effective technology governance mitigates risks and reduces the potential harm to society while also helping to maximize the technology's positive impacts. The digital transformation in industries and COVID-19 has accelerated the use of these technologies. A risk in IoT market can be taken as a good opportunity for building career. A role of an IoT developer is a versatile, being well versed in diverse areas imparts the degree of flexibility in the developer. So these are the references which we have used for this presentation. I hope this gave you some overview of IoT and has given you some food for thought and will help you understand the basics of IoT and will help you in further learning more about it. Thank you so much.